So in this video, we're going to talk about the importance of professional societies within engineering. And before we begin with that discussion, I'm going to talk a little bit about the importance of professional societies in general, because we'll see that our engineering professional societies, of course, resemble a lot of the characteristics of general professional societies. So when you think about what a professional society is doing, it's trying to, and hopefully the definition is a little bit intuitive or straightforward to you. What a professional society is a collection of individuals that identify with the same occupation or the same trade. And that's a pretty tight definition. Oftentimes what you see is professional societies might not only consist of individuals in that vocation, but also stakeholders that are impacted by that vocation. So for example, as we'll talk about in a minute, IEEE, the predominant Society for Electrical and Computer Engineering, allows membership by non-engineers within that professional society. But usually what you will find is that the vast majority of members are associated with that vocation. So when you think about why professional societies exist, they're predominantly educational in nature and informational in nature. And if you think about some of the common functions, not just across engineering professional societies, one thing they do is publish journals and arrange conferences. And really that's about the educational function that we mentioned above. When you think about the state of the art or the body of knowledge within your domain, who is going to know it better than the people that are actually practicing within that vocation? So it's natural that they would fulfill that educational function in order to ensure quality of the body of knowledge and timeliness of the body of knowledge. In addition, raising public awareness of the discipline, that could be for an outreach or recruitment perspective, like we talked about in the prior video, or it could be from kind of the lobbying perspective. Maybe in the medical field, you want to lobby your lawmakers in order to influence some policy that may relate to your compensation or the ability to do your work. In addition, recognizing excellence within the field, again, kind of the same argument as the first bullet, who would be better to identify that person is an excellent electrical engineer than a collection or a professional society of electrical engineers. So I 2 years ago or 3 years ago, time flies now, was elevated in membership to a senior member of IEEE, and that is kind of reserved for a subset of individuals that are nominated by other senior members and approved by a committee based upon demonstrating significant contributions to the field of electrical engineering. So if you think about when professional societies were found, and I have a graph of them over time here to the right, and I have some particular dates here, but the main thing I'm trying to show you with that graph is that there was kind of an acceleration, an inflection point in this either cumulative or point exponential curve around the time of the Industrial Revolution. So beyond those functions that we talked about above, another really common, really critical function of engineering professional societies and some other societies in general is to maintain technical standards. And we're going to talk about what those are in more detail in the context of IEEE, because I think it's easy for people to understand, because these standards are so critical in the development of the consumer technology that you use on a daily basis. But really what technical standards are doing is they're ensuring efficiency in the design process. And if you think about it, you're watching this video right now on some sort of computing device that is probably connected wirelessly to your internet. So whatever computing device you're using, your laptop, your phone, it's communicating with your router. The laptop and that router were not made by the same individual. So when they want to design communication interfaces and hardware to talk to one another, you don't want to have one manufacturer have to call the other and say, hey, can you give me that protocol of how you're sending the bits over your Wi-Fi channel and I'll design a receiver to match it. No, you want open source, ideally, and not necessarily in the particular design, but in the interface protocols of that communication standard. And that will allow individuals to ensure that when they design hardware, it can integrate naturally into whatever technology ecosystem you have. That's going to create a more efficient design process. Products are going to get to market quicker. And in addition, because everyone can focus on individuals, not from just a particular company, but a variety of stakeholders, and maybe even research and development or federal nonprofit institutions as well, they can all get together and agree on these particular technical standards and assess them very rigorously. So you have some assumption of quality in that the standards that individuals are designing should produce very reliable products, and they, in the case where it makes sense, they should be very safe products as well, because there's a lot of eyes on them and a lot of review, not just by one company. So when you think about professional societies within engineering, the one thing you should know is they're predominantly organized according to engineering subdisciplines. However, you can have professional societies that are organized according to some other factor. Maybe it's a demographic factor, or maybe it's a particular professional distinguishing distinguishing factor, or so on. So on the actual engineering subdiscipline side of things, we talked about IEEE. That's actually the preferred way to pronounce it, even though it's an acronym for Institute for Electrical and Electronic Engineers. We have the American Society for Mechanical Engineers on the mechanical engineering side of things. In addition to the subdisciplinary organization, you can have demographic factors like the Society of Women Engineers, or SWE, or SHPE, or NSBE. I'm sure that many of you have heard of those, but you're going to have an opportunity to dive into those as part of the homework this week. In addition, you have the NSPE, which is the National Society of Professional Engineers, or those individuals that have went through the professional licensure process. So I wanted to talk to you a little bit about IEEE, just since it's the largest association of technical professionals in the world, not just engineering. It was formed in 1963 through a merger, basically, of individuals that were interested in power distribution and those that were interested in radio. They kind of joined forces and created what would be the world's largest technical society. There are over 400,000 members in 160 countries, the majority of which are outside of the US. A very, very large chunk of student members. That's one thing that's common in these professional society clubs. They focus on recruiting at colleges, and unfortunately, a lot of people don't maintain activity after they leave college. And the main reason is, to be frank with you, the price of being a part of technical societies traditionally accelerates quite a bit after you leave college. Some employers will help subsidize or pay for it entirely, but some people just don't see a value proposition in the cost of maintaining a membership after they transition. In addition, what you'll find, it's very common in IEEE and other engineering societies, is you can have sub-organizations within that professional society. So a technical society within IEEE is a group of individuals that are focused on a particular technology domain. A technical council is kind of a superset of those technical societies. So if you have a problem that multiple technical societies would be interested in, you can form a technical council. In addition to being organized around actual technical domains, you can organize subsets of IEEE according to geographic proximity. So the entire world is divided up into 10 regions. Within each region, you can have individual sections, and there are 343 geographic motivated sections of IEEE in the world. Here in San Antonio, ours is called the Lone Star section. One of the reasons I wanted to talk about IEEE in detail is it gives me another opportunity to refer to the importance of standards within engineering design and the role of technical societies and kind of driving those standards. If you think about it, they're the natural organizational structure to make it happen, because in order to belong to IEEE, for example, all ideally that you have to be is an electrical or computer engineer. It doesn't matter where you work. It doesn't matter where you live. So you naturally can get together a lot of stakeholders that have broad representation across anyone that would be impacted by that technology. So within IEEE, the Standards Association is called IEEE SA. Here is a link to a video that you can watch that provides an overview of why standards are important, but hopefully it's pretty intuitive to you. You can see that there are a lot of standards that are currently in active development, a lot of them that have been transitioned into the historic portfolio. So what I'd like you to do is just kind of play around on the web and see if you can find the way that IEEE actually identifies their standards. So for example, now, if you think about the way that your Wi-Fi connection is working between your computing device and your router, that kind of communication protocol of how many bits you're going to send, what frequency you're going to send them in, kind of the meaning of the structure in the packet. That is all governed by an IEEE protocol that's called 802.11, 802.11. That's the way that IEEE numbers their standards. You'll see that there's a similar standard for Bluetooth. If you've ever bought a pair of wireless earbuds offline and paid nothing for them, and you're like, there's no way these could work, and they pair with your phone right out of the gate. The reason that they pair with the phone right out of the gate is that they're both designed according to the common IEEE Bluetooth, probably BLE standard now. So I don't want to just be biased towards IEEE, just to give you some information about another large professional society within mechanical engineering, ASME. It was formed in 1880. There are over 85,000 members in 135 countries. So you see the common thread of being large and being international. Again, 23,000 student members. So a larger portion of student members than you would necessarily expect, given that students aren't necessarily working within that domain. It's the same kind of recruitment strategy that I taught for IEEE. In addition, ASME is heavily involved with standards. As you might expect, a lot of these are in the kind of manufacturing industry, maybe related to D&T, dimensions and tolerance, or even standards in engineering drawings. So when you think about there we go. I didn't know the slide was coming. Sorry, I surprised myself. So really what they're trying to do is ensure commonality and efficiency when you actually have assembly, or if you're going to take and design a product and you're going to send it offshore or to some other company to make, you want to have information within your engineering drawings and prints organized in such a manner that there's no confusion when someone is actually running the production process or running the assessment process of what the dimensions are, what the particular instructions are, and the tolerances as well, of course, are very important. So hopefully that gave you a good idea of the function of professional societies along with the function of professional standards.